Computing basics. The first computers were used primarily for numerical calculations. However, as any information can be numerically encoded, people soon realized that computers are capable of general-purpose information processing. Their capacity to handle large amounts of data has extended the range and accuracy of weather forecasting. Their speed has allowed them to make decisions about routing telephone connections through a network and to control mechanical systems such as automobiles, nuclear reactors, and robotic surgical tools. They are also cheap enough to be embedded in everyday appliances and to make clothes dryers and rice cookers smart. Computers have allowed us to pose and answer questions that could not be pursued before. These questions might be about DNA sequences in genes, patterns of activity in a consumer market, or all the uses of a word in texts that have been stored in a database. Increasingly, computers can also learn and adapt as they operate. Computers also have limitations, some of which are theoretical. For example, there are undecidable propositions whose truth cannot be determined within a given set of rules, such as the logical structure of a computer. Because no universal algorithmic method can exist to identify such propositions, a computer asked to obtain the truth of such a proposition will, unless forcibly interrupted, continue indefinitely, a condition known as the halting problem. See Turing machine. Other limitations reflect current technology. Human minds are skilled at recognizing spatial patterns, easily distinguishing among human faces, for instance, but this is a difficult task for computers, which must process information sequentially, rather than grasping details overall at a glance. Another problematic area for computers involves natural language interactions. Because so much common knowledge and contextual information is assumed in ordinary human communication, researchers have yet to solve the problem of providing relevant information to general-purpose natural language programs. Analog computers. Analog computers use continuous physical magnitudes to represent quantitative information. At first they represented quantities with mechanical components, see differential analyzer and integrator, but after World War II voltages were used. By the 1960s digital computers had largely replaced them. Nonetheless, analog computers, and some hybrid digital-analog systems, continued in use through the 1960s in tasks such as aircraft and space flight simulation. One advantage of analog computation is that it may be relatively simple to design and build an analog computer to solve a single problem. Another advantage is that analog computers can frequently represent and solve a problem in real time, that is, the computation proceeds at the same rate as the system being modeled by it. Their main disadvantages are that analog representations are limited in precision, typically a few decimal places, but fewer in complex mechanisms, and general-purpose devices are expensive and not easily programmed. Digital computers. In contrast to analog computers, digital computers represent information in discrete form, generally as sequences of zeros and ones, binary digits, or bits. The modern era of digital computers began in the late 1930s and early 1940s in the United States, Britain, and Germany. The first devices used switches operated by electromagnets, relays. Their programs were stored on punched paper tape or cards, and they had limited internal data storage. For historical developments, see the section Invention of the Modern Computer.